Okay, now we're going to run some commands from Linux and make sure that everything works. If I can find my lab sheet. Okay. So we ran these first 4 commands from Windows. Now we're going to run the commands from Linux. Same thing. If it says x.x, that would be one of the other side's machines. If it says x.y.y, that would be your other machine. In this case, the first one we're going to run against either of the other side's machines, and this one we're going to run against your other Linux machine. And the first time we do that, I'll show you why we're doing it just the Linux machine. So we'll make sure the network is still up because I stepped away for a few minutes. Let's make sure everything's still working. This machine is 20. Let's get my diagram out. This machine is 20.2, so I should still be able to get to 10.2, 30.2, and 40.2. So let's make sure that's the case. What the heck? 20.2, 10.2, 30.2, and 40.2. Sorry about that. So I can get to everything. I'm going to go ahead and put a filter on when I start capturing. Start. Oh, wait. No interface selected. Capture interfaces. I'll do E0. Start. And I'm actually not going to put a filter on yet. What is... Oh, I am going to put a filter on. I'm connected remotely. I'm connected remotely, so my connection traffic is showing up. So I want to get rid of that. 92, what the heck just happened? Alright, I don't know what just happened. Wireshark blocking up. That doesn't look good. So let's see if oh, there we go. Back 192. Here, let's stop this. Die. Force quit. Alright, so we're going to do that a little differently. This is a good case for having a capture filter. So let's go options. I'm going to put a capture filter of host, or I think a not host 192.168.10.3, which would be my machine I'm using to connect remotely. And now let's start. And now I'm only getting a lot less traffic. So that's good. Still some nonsense though. So we will all right, let's put another capture filter on. So I'm running this in a VM, so I'm also seeing traffic from my host machine, which is the Windows machine that's underneath, which is 20.3. So I'm going to take that off. So not host 10.3, not host 20.3. So that's going to take care of traffic from my machine I'm connecting from remotely with remote desktop. This is going to take care of my traffic from the Windows machine I'm on that's cluttering things. So now let's see what we get. We should get less traffic. There we go. Just some DNS queries and some ICMP error messages. So that's good. That makes it a little more readable. So let's go ahead and look at what we're going to do. We're going to do a traceroute from Linux. We already did traceroute, right? Why are you so lame making us do it again? Well, because traceroute works different on Linux. So we're going to do it from Linux. Also, the command is different. On Windows, we did traceRT. On Linux, we actually type out traceroute. And then the IP address we want to trace to, which will be one of the machines on the other side. And there we do that. So it's doing it. See if we get any replies back. It's taking longer than one would expect. Oh, there we go. We finally got a reply back. 20.1, which is my router. Oh, 50.2, which is the serial on the other side. And eventually we should get 40.2. And 40.2. That took a lot longer. I don't know why. Let's go ahead and stop this and go see what we got. So if we look up here at what we're sending, how do you know what you're sending? Well, you kind of just have to know what's going on. So hopefully you're paying attention to this. There we go. So here are some UDP probes. Remember with Windows traceroute, we send ICMP packets. With Linux traceroute, we send UDP packets. So if we look at our UDP packet we're sending, open, fool. All right, fine. If we look at our UDP packet, we're sending UDP to some destination port, a traceroute port, right? And if we look at the IP time to live, our time to live is 1. So this worked exactly the same way the Windows traceroute worked. It just used UDP instead of TCP. So the time to live was 1. It would have got decremented to 0, and the error message would have came back from the router. Holy cow. Let's go back up and see if we can find one of those replies. There we go. So here is one of the replies. Time to live exceeded, right? If we look down in the ICMP section, we'll see that that is code 11 type 0 again. Here we have our original datagram. So we look at that. We can see that indeed the time to live was set to 1, so this was one of our probes. But the interesting thing about Linux traceroute is you also lots of times get port unreachable messages. Why? Because that is the ICMP error message that comes back when you send a UDP port to a port that is not listening. So this traceroute port, if you will, port 34,000 or whatever it said it was, 33,437. These ports that it's using, these high number ports, aren't really listening on the machine, right? So you're also going to get a destination port unreachable message. So let's look at the lab sheet. Traffic just generate. Wait, that's not right. Linux. Here we go. What traffic did this command generate? It generated UDP packets with low time to live values. Put some frame numbers. ICMP reply. You should have 2 answers for this. We got a ICMP time to live exceeded in transit, which was 11.0, I think. Code 11 type 0. Is that right? Type 11 code 0. And then we also got these destination unreachable messages that were type 3 code 3. So that takes care of that. The next probe, we're using this hping command, which hping is a tool that allows you to craft arbitrary packets. So if you want to make a packet look like something, you can use hping to do it. So what this is saying send a probe to UDP port 99, send 1-C1, one packet to port 99 UDP to your partner's Linux machine. So we'll do that. Capture, start. Continue without saving. You, of course, will be saving these things. So we're going to do hping --UDP -C1-P99, and then the IP address. I don't think it matters if you have a space or not. And the IP address 192.168. Let's look at what my partner's Linux machine is. My partner's Linux is 40.2. So these next set of packets will be going to 40.2. Get out of here, fool. 40.2. I'm going to go restart Wireshark since it took me so long to type the command. And go. And then I'll stop it. Capture, stop. So this is the same thing we got before in our traceroute. Right here we send a UDP packet to 40.2 port 99. Why port 99? I don't know. I just picked the port I knew wouldn't be listening. If you actually send it to the port that is listening, you will get a different response or no response. And then here's our error message: port unreachable, type 3 code 3, meaning that port is not listening on that machine. All right, next we're going to do ICMP timestamp request. hping --ICMP timestamp -C1 and then the IP address of my Linux machine. I did tell you I was gonna tell you why we're doing the Linux machine for these. We're doing Linux machine for these because the Windows machines, at least the XP machines we used to have, did not respond to all these packets. So so that one it did respond. That one we got an ICMP port unreachable back from the Windows. Now we'll try the timestamp request to the Linux. And that was ICMP-TS. Check my sheet to make sure I get the command right. -C1. So this is going to send an ICMP timestamp request, and we should get a timestamp reply. Capture, start, continue without saving. So there, we sent a timestamp request, which is type 13 code 0. We got a timestamp reply, type 14 code 0. Let's go ahead and do that to the Windows machine for fun and see if we get a reply for that one. I know some of these didn't work with Windows XP, but perhaps they have updated Windows 7 so it responds to things. Yep, and Windows 7 did reply. Interesting. Alright, so the next one. Oh, what did this command generate? It generated a timestamp request. The reply was 14.0, type 14 code 0. The reply was a timestamp reply. Reason for response, because we sent a request and it replied. This packet, fun enough, is going to set the more fragments flag. That's what the -X mean. It's going to set the more fragments flag, but we're not going to send any more fragments. So eventually, we're going to get a ICMP error message that says fragment timer timed out, reassembly time exceeded. If I can find my lab sheet, it's going to be hping. Oh, hping -ICMP-X -C1 192.168.40.2. Let me verify that command is correct. C40.2. So we'll send this. We'll restart Wireshark for fun. Capture, restart. We'll send this. We'll wait. There we see our fragmented IP protocol. That's what we sent. We keep getting some error messages, but not the one I want to see yet, because this has to wait a few seconds for the timeout time to expire. And we're still waiting. There we go. And there it is. So on this one, you need to wait, I don't know how long that was, 20 seconds or something. Let's go back up and look at the original packet. Here I send fragmented IP protocol, so I used hping to send a packet that has the more fragments bit set. But I didn't send any more fragments. So what happened was our destination machine grabbed that fragment and then waited for the other fragments to come, and no more fragments ever came. So it got sad. And then it said, I'm sorry, but I didn't get all your fragments. So here we have the reply, which is that ICMP reply we're going to look at. ICMP reply. We have time to live exceeded, fragment reassembly time exceeded. So type 11, code 1. All right, let's find our lab sheet. Type 11, code 1. Oh, what did this command generate? It generated a packet with a more fragments bit set. Get the frame number. ICMP reply was time to live exceeded, fragmentation or reassembly timer expired, or whatever it said. Type 11, code 1. Type 11, code 1. Reason for response, because it didn't get the rest of the fragments. Oh, up here. It didn't get the rest of the fragments. Okay, this last one we're going to do is we're going to send a packet to a protocol that does not exist. This -8, this -0 means like raw mode, and -8 means set the protocol field to 9, and we're going to send one packet. So let's go do that and see what happens. Yeah, why do I keep opening that? That's not what I want. Come on, get out of here. All right, I want you to go away, -0 capital H. So we're going to do hping -0, that's not an O, this is 0 capital H 9, and then -C1, and then the IP address of the other Linux machine. There you go. Did that not restart? Stupid. I said start. Continue without saving. All right, there we go. All right, so that should have done it. Let's go see what we got. All right, so it shows up as a malformed packet. Why is it a malformed packet? Because Wireshark is smarter than us. All right, if we look at what I did, I said set the protocol field to 9. So if we look at the protocol field in the IP header, it is 9, right? 9 apparently means IGRP, which is a routing protocol, but then we didn't send any actual IGRP data into our packet. So Wireshark says, hey, yo, that packet's not right, which is true. That packet's not right. And then here's the reply from the other side. Destination unreachable, protocol unreachable. So basically, we tried to send an IGRP packet to a machine that is not running the IGRP protocol. So if for some reason, not like this could ever happen, I don't think, if for some reason you turn TCP off on your machine and somebody tried to send a TCP packet, that would be the error message you would get, protocol unreachable. So that's the error message for that. All right, and that takes, oh wait, let's look at the typing code. So again, if we wanted to get frame numbers, this would be frame 4 for the probe, frame 6 for the reply, and let's see, type in code would be type 3 code 2. Type 3 code 2 ICMP reply, protocol unreachable. Reason for response, the protocol, the IP protocol 9 was not available on the remote machine. And that is that.